Forget frequently asked questions,
common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast. My guest is from Japan, Yoshifumi Saisho. He's at the Department of Internal Medicine, Keio University in Tokyo. We're going to talk about an aspect of diabetes. So, Yoshifumi-san, thank you for coming. How are you doing?
Hi, Richard. I'm fine. Thank you for having me on this podcast. Nice to meet you.
Well, tell me about your research, please.
So, I'm a physician working at the University Hospital in Japan. When I became a doctor, I would like to be a doctor who can see the entire patient rather than some specific organ, for example, heart or stomach. Also, I am interested in prevention of the disease, which can control the disease at least in part by ourselves. Therefore, I chose internal medicine and diabetes as my specialty. So when I was a medical school student, I have learned that type 2 diabetes is characterized by obesity, insulin resistance, and compensatory hyperinsulinemia. However, when I graduated from the medical school and saw the patients as a doctor, I noticed that many patients with type 2 diabetes are not obese in Japan.
Oh, really? So in Japan, people have diabetes, but they don't tend to be obese?
Yes, it's kind of interesting, but the mean BMI of patients with type 2 diabetes in Europe or America is approximately 32 or more. But in Japan, the mean BMI of patients with type 2 diabetes is approximately 24 or 25.
Wow.
Smaller than Caucasians.
I think that's the limit here for being considered overweight.
Yeah, but also the proportion of patients with diabetes, incidence of patients with type 2 diabetes is almost similar between Japan and America, U.S.A.
Really?
So, we think we are more susceptible to get diabetes with less obesity compared to Caucasians.
Well, how has the diet of the typical Japanese person changed over the past, I guess recently, the past 20 years?
After World War II, we are changing our lifestyle very much. So we are now, a Western diet is very popular in Japan as well. So Westernized diet and sedentary lifestyle is the cause of increasing diabetes in Japan as well as in other countries.
Oh.
I would like to talk about that the difference between, I think the difference between Caucasians and Japanese in terms of phenotype of type 2 diabetes is due to the difference in beta cell mass or function. So I will talk.
What are, for listeners, what are beta cells?
Beta cells. Beta cells secretes insulin. So insulin is the only hormone which can lower blood glucose level in our body. So and the beta cells are scattered. Other beta cells and other endocrine cells are scattered as a cluster called as Langerhans islets within the pancreas.
Mm-hmm.
So we have 1 million Langerhans islets in our pancreas, but collectively, total of beta cell mass is only approximately 1 gram in our body. So this tiny organ controls the blood glucose level in the body within very narrow range. That is 70 to 120 milligram per deciliter. So it's a very precious organ within our body.
So 1 million beta cells only weigh about a gram?
Yes. Million islets, so cluster of beta cells, only account for 1 gram.
Wow. Huh.
Very, very tiny organ. Yeah.
When people get diabetes, how many beta cells do they have left? Has anyone measured that on average?
So we can measure, we can evaluate beta cell function by measuring plasma insulin or C-peptide levels, which is a marker of insulin secretion, endogenous insulin secretion. But unfortunately, it's not possible to directly measure beta cell mass in vivo in humans so far. So to clarify the physiological and pathological changes in beta cell mass in humans, we are using autopsy samples or samples pancreas from the patients who underwent pancreatic surgery, and we use by using these pancreatic tissue samples, we are measuring beta cell mass by immunohistochemical techniques. As a result, we and others have shown that the beta cell mass in humans is reduced by somehow 30 to 50% in patients with type 2 diabetes.
Yeah, so what happens when someone starts having chronically high insulin and they become diabetic? Do their beta cells die, or do they shrink, or do they become ineffective? Like what happens?
Yeah, so there are many studies to understand this mechanism, but we don't know yet the definite mechanisms. But I think there are many mechanisms contributing together for reducing beta cells. So one of the mechanisms is beta cell apoptosis. Here we propose beta cell workload is one of the mechanisms of beta cell loss in humans.
So beta cells, again, they apoptose and they also shrink. Like what else happens to them?
Yeah, so beta cells are collectively only approximately 1 gram. So this tiny organ with 1 gram in weight controls our plasma glucose levels within very narrow range. So when we eat excess carbohydrate, especially sugar-containing snacks or beverages, so beta cells secrete more insulin to keep plasma glucose levels within this normal range. So in rodents, such as mice and rats, the number of beta cells increases 2 to 3-fold in response to obesity. In contrast, studies using human pancreas tissue have shown that the number of beta cells does not increase in humans as much as in rodents, that is by 0 to 50%. This means that in humans, individual beta cell works harder and secretes more insulin in response to obesity and insulin resistance. So we call it increase in beta cell workload, which is already present before onset of diabetes. So in our society, if we are forced to work hard for a long time, we will be overworked and exhausted. So beta cells are the same. If beta cells are forced to work hard, many intracellular stresses such as ER stress, oxidative stress, and amyloid toxicity occur within the beta cells. So these stresses impair beta cell function and maybe eventually lead to cell death called apoptosis in the end. So karoshi. Karoshi is a Japanese word which means death due to overwork. So it's not surprising that the same could occur in beta cells.
Huh. So what about in type 1 versus type 2 diabetes? Has anyone profiled the beta cells to see how they're different?
Yes. So using human pancreas tissue, there are many reports. So diabetes is classified as type 1 and type 2 diabetes. So type 1 diabetes is an autoimmune disease in which pancreatic beta cells are destroyed by immune cells, leading to insulin deficiency. So in the pancreatic tissue, we could find only small portion of beta cells, approximately 10% or less than that. On the other hand, type 2 diabetes is classically characterized by obesity, insulin resistance, and compensatory hyperinsulinemia. Therefore, in contrast to type 1 diabetes, type 2 diabetes is often considered as a disease of insulin resistance, but not a disease of beta cell.
But it is
However,
also a disease of beta cells too, you're finding, yes?
Yes, that's right, that's correct. So however, recent studies using human pancreas tissue have revealed that pancreatic beta cells are reduced in not only people with type 1, but also type 2 diabetes. So one of the most famous papers in this field elegantly showing reduced beta cell mass in humans with type 2 diabetes by Peter Butler and colleagues, who is also my mentor, has been published in 2003. So this suggests that beta cell deficits are common pathogenesis in both type 1 and type 2 diabetes. Moreover, recent studies, including our study, have also suggested that beta cells are reduced already before onset of diabetes in both type 1 and type 2 diabetes. So these findings strongly suggest the importance of prevention of diabetes, and beta cell protection and preservation is important to prevent diabetes.
So what are some ways in which you can preserve your beta cells? Have less sugar? I mean, what, is it obvious? Like what can be done?
Yeah, so there are many drugs and new drugs have been developed so far, but still lifestyle modification, avoiding intake of excess calories and especially sugar, and avoiding physical inactivity is a very, very important and fundamental treatment for type 2 diabetes. And also it lower beta cell workload, so leading to beta cell protection, we believe. Because in humans, beta cells has a low ability to proliferate, especially in the adulthood. So it's important to preserve our original beta cells to prevent and manage type 2 diabetes.
So in people that, let's say, they go on a low carb diet, have their beta cells been looked at to see if they regrow or they proliferate again?
Yes, that's a good question. It's still remains unclear because we cannot directly measure beta cell mass, but beta cell function can recover by low carb diet or especially weight loss.
Okay. So the function recovers, but what if half of the cells are already dead? Do any of the cells regenerate and grow back or proliferate again, or no?
So far in rodents, mice and rats have a capacity to proliferate their beta cells, but in humans we have less capacity because we have reported that using human autopsy pancreas, the beta cell mass is increased only 50% in obese non-diabetic subjects, Caucasian subjects, compared to lean non-diabetic subjects. So usually in rodents, they can increase 2 to 3-fold. They can increase beta cell mass 2 to 3-fold. But in humans, we have less ability to proliferate beta cell mass. So it's very important to preserve and protect beta cells by reducing beta cell workload.
What other cells are in the pancreas that seem to be affected by diabetes? Is it just beta cells, or are there other cells that are affected as well?
Yes, there are alpha cells, delta cells, and also PP cells and epsilon cells, other than beta cells within other endocrine cells within the pancreas. So they also contribute to glucose metabolism or insulin secretion. But among them, alpha cells secreting glucagon is very important factor for glucose metabolism because glucagon increases plasma glucose levels.
Okay. So what do you hope to figure out with your research?
So we are mainly using pancreas tissue, human pancreas tissue, to clarify the physiological and the pathological change in beta cell mass in humans. And we now know that the ability to proliferate beta cells is unfortunately small, very small in humans. So it's very important to preserve beta cells. So we know the lifestyle modification is very important, but also it's very difficult to continue lifelong. So I would like to propose beta cell workload hypothesis, which makes, I believe that paradigm shift from glucose-centric to beta cell-centric concept of diabetes.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
Well, how do you measure beta cell workload? How do you gauge that? Have you tried to cycle beta cells?
That's a good question. It's difficult to workload. Unfortunately, there is no reliable marker to detect beta cell workload, but we can still see maybe future study will reveal the change in metabolite or metabolome analysis can find some marker for beta cell workload. But so far, we can only see beta cell function by challenging a test meal or glucose challenge or glucose clamp test to measure beta cell function.
Oh, well, what constitutes beta cell function? Is it the amount of insulin they put out per hour or how do you gauge beta cell function?
There are some several measures of beta cell function, but usually insulin secretion ability to basal or change in glucose level.
Is there a quality of the insulin produced? A speed?
Yes.
Are there other characteristics of it that tell you, the condition of the beta cells?
So glucose sensitivity of beta cells is one of the marker of beta cell function.
Okay. Are there any other markers that are important? Again, speed of insulin production or speed of blood sugar reduction?
Speed of blood sugar reduction, yes. Yes, both of them are very important to measure beta cell function, but we'd like to propose a concept of diabetes. So as I mentioned, type 2 diabetes is classically characterized by obesity, insulin resistance, and hyperinsulinemia, right?
Right. Okay.
But recent studies have shown that the beta cells are already reduced in patients with type 2 diabetes. And as a physician, I'm interested in, so my goal is to provide the best possible treatment of diabetes to the patients and to support them to live a healthy, happy, and satisfying life with their disease. And also, in addition, my ultimate goal is to prevent and cure diabetes, although then I lose my job. So I'm seeing the patients who have unfortunately developed diabetes, but we also need to talk to the people who do not yet develop diabetes and do not visit the hospital for prevention of this disease. So then also we need to develop more effective strategy to prevent diabetes. And for this purpose, so I would like to propose a paradigm shift of the concept of diabetes from glucose-centric to beta cell-centric concept of diabetes.
So what else is different about people in America and people in Japan that are diabetic? You said in Japan, people have less body weight, but what other differences are there? Any other differences?
Oh, yeah. BMI and insulin secretory ability is different between Caucasian and American and Japanese. So I'm interested in seeing is that there are different phenotype in patients with type 2 diabetes between Japanese and Caucasians. So in general, type 2 diabetes develops in people with obesity. So, but we in Japan, we are less obese. So regarding this, we have found by using the histological analysis of human pancreas that the number of beta cells was not increased in Japanese obese individuals without diabetes. while the bed cell mass is increased by 50% in Caucasian obese individuals without diabetes. So this suggests that Japanese are more susceptible to develop diabetes with less obesity due to the lower ability to increase our bed cells. It's a hypothesis, but the recent genetic studies, genome-wide association studies have also found a difference in genes between Japanese and Caucasians, which may relate to bed cell function or bed cell mass.
Why do you think that the Japanese are not able to handle, this sugar load or this this insulin load?
Yes.
As well as other cultures.
Yeah, that's a big question, but maybe genetic factors associated with this difference, but also some environmental factors also could be involved in this difference. But genetic factors and environmental factors interacting very complex interaction. So we have recently reported also by using pancreatic tissue obtained from the patients who underwent pancreas surgery. We have found that there is an association between birth weight and bed cell mass in adults. So lower birth weight is associated with lower bed cell mass in adults. So birth weight may be one of the determinant of bed cell mass in adults, in humans. And also we found that childhood obesity is also associated with increased bed cell mass in adults because bed cells proliferate. But in humans, we can only see sufficient proliferation in bed cells only during early life, maybe before 5 years of old. So then bed cell proliferation ability declines, and there is very low proliferation ability of bed cells in adult humans. So childhood obesity may affect bed cell proliferation. So the different environment during the early age or early childhood may impact on the amount of bed cell in the adults. So, but we need more studies to confirm or to explore these factors.
Have you looked at the morphology and the size of beta cells in different populations to see if there's differences?
Different population means Caucasian and Japanese, you mean?
Yeah, young and old, Caucasian, Japanese, etc.
Yes. I saw the histology of pancreas of Caucasian and young and old and lean and obese. So they have a different morphology of the pancreas, and also the amount of bed cell is substantially different between individuals. So there may be a environment and genetic factor is associated with the amount of bed cells, which is also associated with susceptibility of development of diabetes.
But what are some of the differences that have been observed in different people, in different populations?
So between Japanese and Caucasians, as I mentioned, there is a difference in change in bed cell mass in response to obesity. And also older population and the pancreas exocrine tissue is very atrophic, and they have a smaller pancreas compared to the younger population. But we found that bed cell mass relatively preserved in these obese, not obese, in old populations. So we have a very small ability to increase bed cell mass, but we have ability to preserve bed cell mass lifelong, I think.
What percentage of beta cells are compromised in someone that has diabetes typically? And are there different levels of compromise?
Bed cell mass is reduced by 20 to 65% in patients with type 2 diabetes compared to patients without diabetes. So almost half is compromised.
Huh. So at that point, the person is, a typical diabetic person will have, 40 or 50% of their beta cells gone, or just diminished in size?
Usually in the reduced number of beta cells, not the size of individual beta cell. So that's what we saw in the pancreatic tissue. So the number of beta cells are reduced by half in patients with type 2 diabetes. So this suggests that prevention of diabetes is very important before development of hyperglycemia.
Okay. Does this suggest to you any other methods to preserve beta cell function?
To preserve beta cell function? So yeah, there are many new anti-diabetic medications have been developed. Some of them have been shown to improve beta cell function. But still, lifestyle modification is very important, because if we change our lifestyle and lose our weight, the insulin resistance is reduced, which means beta cell workload reduced. So the reducing beta cell workload is so far the most effective way to preserve our beta cells. So if we consider our beta cells in our mind, maybe it's useful to motivate to keep our healthy lifestyle for a long time. Do you know what I mean?
Yeah, no, that makes sense. I just didn't know if there's other ways to, again, preserve beta cell function that you have observed. What do beta cells use to produce insulin? What are the precursors or the raw materials they use to produce insulin?
No, I mean beta cells synthesize insulin.
But how? How do they do it? Is that understood how they do it?
Oh yes, it's transcript from DNA and RNA and produce proinsulin, and then proinsulin is cleaved in the Golgi body and ER, and then they put into the vesicle, secretory vesicle, and then cleaved to proinsulin and insulin, and then they secrete from the beta cells.
Okay. What are some of the new drugs that are impacting beta cells in a positive way? How do they work?
So we think that the beta cell-centric concept of diabetes and also beta cell workload hypothesis makes a paradigm shift of diabetes treatment. Prevention and management diabetes should focus on beta cell preservation rather than just correction of hyperglycemia. In the glucose-centric concept, patients with diabetes often become overly anxious about the up and down fluctuations of plasma glucose and glycated hemoglobin, called A1C levels. So glycated hemoglobin, called A1C, is a glycemic marker which reflects the average plasma glucose level over 1 to 2 months. The patients and physicians also primarily judge the adherence to lifestyle modification by A1C level. However, as type 2 diabetes is a progressive disease, A1C level will often worsen over time, which may induce a feeling of ineffectiveness and depression and cause patients to discontinue treatment. In contrast, with the beta cell-centric concept, since patients understand the progressive nature of the disease, they may act to delay the progression of disease irrespective of their A1C level. Also, this may change the relationship between patients and healthcare professionals from confrontation to alliance, fighting together to protect beta cells. So this concept also helps patients to realize the importance of early treatment of preserved beta cells, also preventing clinical inertia. So clinical inertia means that failure or delay of the treatment intensification when it's needed. Finally, this concept will emphasize the importance of prevention of type 2 diabetes to the general population, endorsing advocacy of patients with type 2 diabetes. So by focusing on self-preservation, we can have the same goal, irrespective of presence or absence of hyperglycemia. Patients with and without diabetes can have the same goal. This makes an important difference in prevention strategy of diabetes, I believe. If we have the same goal, irrespective of presence or absence of diabetes, this may help to diminish the stigma of diabetes.
Well, how is diabetes perceived by people in Japan? Is it shameful? Do they
yeah, that's called stigma. Stigma is also a big problem in Japan as well as in U.S.A.
Well, in Japan, though, is it more of a stigma to have diabetes, or is it no big deal?
We are not did not compare with to America, but in the U.S.A. the stigma diminishing the stigma of diabetes called advocacy is very active action in the U.S.A. And here in Japan, we are also trying to promote the advocacy to diminish the stigma of diabetes in Japan recently.
Culturally, you live there. Culturally, do you notice that people take it very seriously, or do they think it's no big deal? Like, what do you see culturally in Japan? How do people feel about it?
Yeah, it depends on the individuals. But that we think that education or understanding of the diabetes correctly is still insufficient in Japan.
Okay, I just didn't know if people saw it very differently there. But what percentage of the population is pre-diabetic or diabetic in Japan as compared to the U.S.?
Yeah, now approximately 8% of the population is diagnosed as diabetes, and also 8% of the population is diagnosed as pre-diabetes. So together, 20 million people are considered as glucose intolerance in Japan.
Well, that's a lot, but the U.S. is much, much more, it sounds like.
Yeah, but still almost similar proportion of diabetes, despite we have less obesity.
Is this a new phenomena in Japan? When did the traditional diet change? Was it more recent?
Yes. But in these days, in 2008, we started the National Annual Health Check, including measurement of waist circumference called the metabolic kenshin. So after 2008, the incidence of prediabetes is now reducing. But still, because of our aging society, aging is also an important factor, risk factor for type 2 diabetes. So the incidence of type 2 diabetes remains to be increased. But prediabetes is start to reducing. So maybe we can change our lifestyle again to the more healthy diet, and people are more interested in the healthier lifestyle in Japan.
You said prediabetes is decreasing? Why is that?
Oh, it may be so that the promotion of awareness of the metabolic syndrome by measuring waist circumference. So we started National Annual Health Check, so including measurement of waist circumference. So that would impact on the Japanese population to know about metabolic syndrome and as well as diabetes, and importance of prevention of this disease.
Well, very good.
National campaign to establish annual health check worked and to educate the people in Japan.
So, Yoshifumi-san, what is next for your research? over the next few years? What do you hope to discover?
I mean, I'm working at the university hospital, so I'm a researcher, but still I'm a physician. So as a physician, I would like to translate the research findings from bench to bedside, but not only bench to bedside, but also from bed to the society for the prevention of diabetes. So the national nations proposed the SDGs, Sustainable Development Goals, in 2015, containing 17 goals to promote healthy and eco-friendly society. Now many companies are interested in the SDGs, the pharmaceutical companies as well. So healthcare providers like us, like me, also should pay more attention to SDGs and share this concept. Regarding this, so mottainai, do you know mottainai? Mottainai is a Japanese word, and the concept of mottainai is now paid attention to promote ecology from the world. Wangari Maathai, Kenyan ecologist and the Nobel Peace Prize winner, was impressed with this word and spread the mottainai campaign around the world. So mottainai is a Japanese term meaning a sense of regret concerning waste when the intrinsic value of an object or resource is not properly utilized. It can be used when something useful, such as food or time, is wasted, meaning roughly or water waste. So there are 3 R's of ecology: reduce, reuse, and recycle. Mottainai contains a meaning of these 3 R's of ecology and also respect as the 4th R. So this may be our culture, and we have a kind of sense of respect to the nature in our daily life. So preserving the resources of our earth is important for ecology and to achieve the SDGs, but also considering that our bed cells are also the precious resource of our body to maintain our glucose metabolism. Preserving our bed cells should also be one of the important actions to achieve SDGs, right? The concept of ecology may be synchronized with the concept of diabetes care. Save the earth can be rephrased as save your pancreas or bed cells. So we need to reduce bed cell workload by pursuing a healthy lifestyle with respect for our body. The bed cell-centric concept of type 2 diabetes helps people recognize bed cells as a limited and precious resource in our body, as an organ with a total weight of only approximately 1 gram that may be lost by overuse. Maintaining a healthy lifestyle may also foster awareness of environmental issues and promote an eco-friendly society. In other words, we need to change ourselves to change the world. Integrating the more common and global goals in diabetes care will motivate people to adhere to sustainable individual lifestyle modification, eventually leading to the achievement of SDGs. Recognition of the global goals will change the way of thinking to one that lifestyle modification is not only for patients with type 2 diabetes, but also for the general population and every one of us. And sharing this concept among people with and without diabetes will possibly diminish the stigma of diabetes and increase advocacy of person-centered diabetes care.
In summary, I mean, we're just about out of time. What is the best way for people to find out more about your work? Where can they go?
Oh, yeah. So you can Google my name, and I will refer you to some of my recent papers.
Is there any other way? So people just, so the best way for them to find you is Google Yoshifumi Saisho,
Yes.
and they will find it.
Yeah, and I will refer you to some of my recent papers on your maybe website.
Okay.
If you are okay. Mm-hmm.
Yes. Well, very good. Well, Yoshifumi-san, thank you for coming on the podcast. I appreciate it.
Thank you very much. I appreciate it. Have a nice day.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at FindingGeniusPodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.